All right. Hello. Welcome to another installment, episode, session, evening, or whatever you might want to call it, of Devcom tutorials. Welcome and hi. So last time, look at this little thing down here. Last time we made our super cool, highly sophisticated modeled player thing. After we made it move at all, we last week finally made it move based on player input, and then we took a look at prefabs. What are prefabs? How do prefabs work? And how, if we have such a prefab somewhere in store in our assets, how can we instantiate this? How can we spawn the asset into the scene to do things like we just made little projectiles, like we made this thing being able to shoot. So it spawns lots and lots of our projectile prefab to get this shooting action done. And today, we look at one of the problems that we had addressed when we finished our session last time, because we've seen that there's when we shoot like this, we have two problems. First of all, we're spawning one prefab per frame, so this is a bit fast. So we need to implement a small cooldown, which is fairly easy. We're going to be doing this at the beginning today, just so I don't know, we spawn like one shot per second or something like that. Also, let's make this value configurable with serialized fields, like we've done pretty much all values, because no hard-coded values. And once we've done this, once we have done the cooldown, we still have the problem that we have a ton of prefabs left over. If I minimize this back down, you can't see it too well in a little preview down in the corner, but you can already see that I can scroll down here. I can scroll and scroll and scroll, because those are all the projectile prefabs that we've spawned. Because if I go down to the very, very bottom of the list and I keep shooting, I keep spawning new projectiles, you see all of a sudden I can scroll down even further, because every single projectile that we spawn into the world, it will then exist forever. So we have to take care about removing them again once they are not used anymore, in case they didn't hit anything, because they're still going. They're still eating up CPU time. Not sure if you can. Yeah, I'm not sure if that's actually we can. Let me try to spawn quite some more of these little projectiles, and then let's see if we can see something in the CPU load or something in Task Manager. You can see it's going up, it's rising, because all these projectiles, even though we're not seeing them anymore, and even if I look up here, they are, you can even full screen you can barely see them, because they are so far away, because they just keep moving. They just keep moving. They do their code, and they still exist. And this is something we do not want, because once the projectile is not used anymore, we want to get rid of this again. And this is the second thing we're going to be looking at today. What to do with not only a prefab, basically any game object, because when we instantiate our prefabs, they basically just become normal game objects in the scene. So there's not much of a difference of game objects you've statically placed in there as well, in the first place in the scene. So we're going to be looking at how to get rid of game objects that we don't need anymore, because, well, they're of no use. They're out of bounds. They're gone. We don't need them anymore. So let's destroy them. Let's say hi to Lakeside. Hi, a wonderful evening to you. Nice you can join. Greetings. So yeah, how to get rid of all these things, these things, and little spoiler alert, next week we then gonna be looking at collisions, because what good is it if we can shoot, but we can't hit anything because our shots, they just pass through everything and don't cause any damage. That's kind of boring, and this is something we're going to be looking at next week. So this week, cooldown, so we kind of control the rate of firing a bit and destroying game objects we don't need anymore to keep our scene neat and tidy and not to clog up our performance with millions and millions of projectiles and other game objects that we don't need anymore for quite some time. So, well, let's get started with all these things. Yeah, and also I have my throat lubricant ready, so I'm gonna see that I reboot my speech center and tune it, so it might do its work a bit better. So yeah, see you on this other side of the following screen, and let's get started, shall we? Yo, and here we are, change place, me in the small view and the project in the big view where you can actually see something. Here you can see a bit better. See, this is our huge list of prefabs we just spawned. Not sure what look at that, CPU is like 25-ish%. So let's spawn some more. You can already see how, without me doing anything, without me scrolling, the scroll bar here already moves up and gets smaller. And you can already see that at first, remember when at first I started these bubbles, the spheres of our projectile, they were, yeah, okay, now they are quite stacked already, because they start to grow apart, because since there's so many, see how the distance grows between them, and even if I let go and start shoot again, how there's more and more distance, because since we have so many game objects already in the scene, and each game object even has code, active code attached to it that is running, because otherwise they wouldn't be moving. All the moving is done by our active code, and this takes up so much performance, so much processing time, that this isn't 60 frames per second anymore already. And if you check our processor, look, the processor load is now, it was at 30% for a short time. But it's a quite good CPU. So we need to have quite some projectiles to actually make a dent in that. But you can already see, especially with the distance between those projectiles, if I stop everything, so our scene is pretty neat and empty. And also, Dana, hi, a wonderful cinnamony evening to you. Yes, the cinnamon cappuccino or any other drink or hot beverage or cold beverage or whatever you like. Everything's better with cinnamon, right? So let's get this moved a bit more here. And you see now they are neat and tidy all together, because now we're running at 60 frames per second, since we don't have that many objects yet. And it would take me quite some time to get them to grow distance again. So you've already seen the negative effect of not cleaning up these objects we spawn. So this is the second thing we're going to be doing today. And the first thing is, and I'm just noticing I don't have my programming IDE open yet. So let's change this. Let's which one do we take? Where did we put the shooting into the movement component? Oh yeah. Oh, I should activate my license. Yeah, I do have a license for this. But for today, it gives me one more day before I have to activate my. I was just lazy. I do have a license for all of these things. I was just lazy. I was like, I come install this here so we can use it. And I was just too lazy to activate my license. So for next week, I do have to activate my license, because next week is more than one day, and I can only go one more day without this precious license. So first exit full screen, whatever that is the default now, and then let's go back into presentation mode so you can see what I'm doing here a bit better. But also I want the Project Explorer and I want my structure, well, window thingy explorer, whatchamacallit it. So we did put, we did put the fire projectile in our movement component. Maybe we should have made a special firing component or can fire component. But this is just for demonstration purpose, so it's fine. We're going to be leaving this at that. Just a bit best practice advice. Break everything. Break your things, your behaviors, your abilities of your objects down into separate components. So this is the movement component because this makes our game object, our player object move. So a better best practice would be to make something like a can fire component or fire component, where we then handle this fire projectile stuff, where we see, okay, is this axis been pushed, and if yes, then go and instantiate the projectile, which again has an own component, a component of its own. And we're going to be tinkering in this one today to make the objects go away again, so we can clean up. But for now, this is okay. So the first thing we want to do is to put the cooldown in there. And this is fairly easy, and I think most of you already have an idea how to implement this. And as usual, there is many ways of doing the same thing. So the cooldown I would like to implement now is that we can only shoot once per second, or whatever amount per second. We make this configurable again. So we say serialize field, and we make this a private float, and we call this firing cooldown. And by default, this is 1 second. So, and later on, now this will show up in the inspector like we've seen before with all the other values. And if we're not happy with 1 second, if this is still too fast, or if it's not fast enough, we can change this in the inspector. Also, if this would become a fully featured game, I'm gonna take some care of some lubrication. 1 second, please. Yeah. I would like to say my throat isn't used to so much talking anymore, but all I did the last 2 days was basically talking because I know at least a few of the people I've already seen in chat have been at the Hamburg Games Conference, and I've been there as well the last 2 days. It was great, amazing conference. They used the Indie Arena booth online system, which was quite amazing, which made quite some advantages. They advanced it, they made it better and nicer and put in more features. Yeah, and basically all I did was talking for the whole day. So maybe my throat now is over-talked. Is there such a thing? I don't think so. So we got our firing cooldown, and the nice thing is that since this now is kind of a configurable value, we could also, if we made this into a game where we have like power-ups you could collect, we could say, okay, power-up speeds up your shooting. It gives you rapid fire. So we could just take a look at this value and divide it by 2. And this would automatically, since in the code where we're doing the cooldown, we'll be referencing this value. So if we have a pickup, this pickup could manipulate this to like divide it by 2. And then we have rapid fire. We shoot twice as fast. And after the amount of time the power-up is active expires, then it can just multiply it back by 2 or something, or remember the original value and then restore it again. There's many ways to do the same thing. This also goes for making the cooldown. So if you would have done it differently, if you would have implemented the cooldown differently, like I'm doing here right now, there's a very, very high chance it's perfectly fine. Because again, there's many ways to do the very same thing, and most of those ways are just right. It's just you had a different idea, you do it a bit differently, that's perfectly fine. So if you do this at home, if you try this, you can do this differently. You don't have to do this how I do. It's not just because I do it, it's set in stone, this is the way to do, the way to go. Absolutely not. So, and then another thing I need is, so this is the firing cooldown. This here we can set the time. The firing needs to cool down like 1 second, so we can only shoot once per second. If we would set this to 2, we can only fire a shot every 2 seconds, but let's keep this at once for now. And then I want another private float. That is my actual fire cooldown. And this will initially be set to 0. And okay, see, and this is why we want to use these highly sophisticated and nice IDEs, because Jesus Christ, what's with my throat? Sorry. Excuse me, but I don't know. It only can get better down the road. So you see there is this yellow squiggly line that tells me, hey, my IDE wants to tell me something, and it tells me the field fire cooldown is assigned by its value never used. Okay, this is not what I was expecting, but this is definitely something that's wrong, because we're not using it yet. Yes, we're assigning it, but we're not using it yet. I was more expecting something along the lines of, dude, this has to start with an underscore. Maybe it does it once we use it. I'm not sure, because this is established convention, because there's a coding style, there's a convention on how you name your fields, how you name your methods, how you name your properties and everything. And private fields, so if I have this private value that's only accessible in my class, they're supposed to start with an underscore. This is just what the default, the common C# coding style says. So we just do this. So this was actually what I was expecting. But yeah, we're also assigning it something, but we're not using it, which we're going to be doing. We're going to be doing this in our fire projectile, because the way I want to implement the cooldown is that each time we fire our projectile, I will set fire cooldown to the value of firing cooldown. So I will basically copy this value into this value, and then with each frame I will just subtract the delta time. We've talked about the delta time quite a lot the last 2 evenings. The delta time, this value here, time.delta time, tells us the time that passed between the last frame and this frame of the game that's going to be rendered, which means that after a second, this will have amounted up to a second, because if you run at 60 frames per second, or even if you only get, like, I don't know, 56 frames, because one took quite a long time to render, after a second, this will, if you add this up on top of each other, after a second, you will have a second. So this is perfect to keep track of time. If you want to keep track of time of something, we've talked in depth about how multiplying our movement speed by delta time makes our movement speed uncoupled from the frame rate, because at first we had our movement speed, it was linear to the frame rate. If you had a higher frame rate, our movement was faster, and if we're on a lower frame rate, our game was running lower, and this is definitely something we do not want. So if you missed this, I can only highly suggest to go back to the not the previous session, but the one before. because we talked in excruciating detail about delta time there and how we make our movement speed completely independent of the frame rate and making this actually into a units per second value. So no matter what the frame rate is, 6 frames per second, 60 frames per second, 240 frames per second, our movement speed of our objects will always be the same. It will just look nicer and smoother with the higher frame rates. So yeah, we can add up the delta time. So we know how much time left since we started adding up. Or in my case, I want to subtract it down. So my plan is to copy the value of firing cooldown into my actual fire cooldown counter value, or however you want to call it. And then each frame subtracting the current delta time from this value. So once this has gone back to 0, I know that the cooldown is done and I can keep shooting. I can shoot another projectile. So let's do this. Let's down here in our fire projectile where we actually did it. Like here we instantiate our prefab, which is our projectile that we want to shoot. And we're just setting the position, so it's actually positioned where our player object is. If we didn't do this, it just spawned in the middle of nowhere and nowhere near where our player was. Oh boy, my speech center today. Please bear with me. I'm trying to do my best. Cheers to you. Thank you. Yeah, we'll get through this. We'll manage to pull this off. So, my plan was to set my, even the typing doesn't work. If I set my fire cooldown to my firing cooldown, there might be better names to these values. Maybe when you try this at home and you try to replicate what we're doing here, maybe you have better names for your values. I'm pretty sure you have better names for your values, but for now, we know what it is, so everything's fine. So we fired our projectile. Given the axis, the recording button was pushed. We instantiated the thing. We put it onto the right direction. So we basically respawned. We fired our projectile. So right, let's set our cooldown. This has no effect right now because right now we are just setting this fire cooldown value to something, but we're still able to fire each and every frame. And even there's we don't take the delta time down yet. So another thing we could do is we could extend this if. We could say if the input axis fire, if the input axis is triggered, so if it's not 0, which means something's happening on this axis, let's put brackets around this because we want to combine this with another condition, and that would be our fire cooldown has to be smaller or equal to 0. So let's check our logic, and this is why this squiggly equality comparison of flow. Oh yeah, okay. Yeah, okay. This is okay for demonstration purpose. This is because the values, they don't quite perfectly match, so there might be rounding errors. Since we are treating this as a digital input, we're either firing or we're not firing. This is fine for now. For demonstration purpose, this is fine in a production environment. General rule of thumb. In a production environment, if you're working on an actual project, you do not want to see any of these squiggly lines, maybe besides the green ones. In a perfect world, in an absolute perfect world, you don't even want to see the green ones. But sometimes this goes against your coding style you have in your project or your company. So the green ones, even though you would really like to get rid of them as well, they are okay. Like in this local variable can be declared in our scope, which means we could put this here. And now the green line should go away. Oh yeah, and then we could join the declaration. So we could also put this into there and then not have this. And now our ID is super happy. However, for us, this might be different for you. However, I would suggest you do this because this is good practice. I'm not sure if it's best practice, but in my opinion, it's good practice. And I would actually like to hear your opinions about this. But we have this kind of rule in our code that it says all the variables you're going to use down the road in your code, they are all declared at the beginning of a function. So you have like here, see, we have our method move, and right on top, even though there's all these green squiggly lines, we have all the variables, each and every variable that we're going to use down the road, we have it declared here at the top and not somewhere in line. There's exceptions to the rule, like to every rule, but in general, each and every variable that's going to be used down the road, declare it on top of the method. It's just so you have a better overview. You actually know, okay, these are the variables that are used somewhere, and if you're looking for something, you can just you can more easy find that thing and then control click your way through and see, okay, where is it used, and also you might spot typing mistakes or something. So it's generally suggested and good practice to have your variables all on the top, and then just use them down there. Again, there's exceptions. So let me undo all of this. So this is one of the situations where the green squiggly line, that's perfectly okay. What's even more okay is greeting Dudler in the chat. Hi there. Greetings to you. Nice for you to stop by and join us. Hi. I hope you had a wonderful week so far. And well, Thursday is basically almost over. So work-wise, there's only Friday left, and Friday is almost weekend. So this is a happy place to be. Yeah, so this is cool. Again, in a production environment, you really want to get rid of the yellow ones. You do not want to see any yellow ones. But for demonstration purpose, not to blow this up and go beyond the scope of what we want to do, we just keep it at that. Same with those ones, but those actually we addressed. Those actually we did take care of up here. Again, go to the session before the last one, where we had this situation where it told us, look, this is kind of bad. Repeatedly accessing the position of the transform. Remember, cache this in a local variable and then refer to this, and this is exactly what we did up here. So yeah, and now to get stuff done and actually see what we actually wanted to do, we're just dealing with this. So we have our fire cooldown, and also we are checking if the cooldown is smaller or equal than 0. And now we're in a situation where if I compile and start this, we should be able to fire exactly once. We should be able to fire exactly once everything's running. And I'm going to be shooting. Yeah, and there's it. I can fire once and never, ever again. So the cooldown is kind of already working. The only thing that's missing is to actually count down the cooldown. Because we're setting it here, and we're checking it there, and now we actually have to reduce the cooldown counter so it actually does eventually reach 0. So we do this. You know what? We like clean code, and even though this is for demonstration purpose and we do not deal with all the yellow squiggly lines, let's put this into a separate method, because it's always good to have separate things. I don't want to use the term unit, because that's I don't want to play buzzword bingo with you. If you have tasks or things to do, it's always a good idea to put them in separate methods, how it logically fits. So what we want to do now is we want to check the cooldown. We want, if the cooldown is still active, so it's not 0, it's higher than 0, we want to count it down. So I will put this in a separate method that I will call check firing cooldown. And maybe I even get this type correctly. Wonderful. Oh yeah, missing the return type, which is nothing. And all we do is we check. Buzzword bingo is maybe better than, yeah, the bullshit bingo is basically the other word for buzzword bingo. Basically, it's the same thing. It's the same thing. Because when you're playing buzzword bingo, you're basically playing, you know, the other one, because you're trying to sound good, and this is a mistake many people do. They try to use all these fancy technobabble terms they have heard some places, and they think, oh, if I use these words, I sound like I know what I'm talking about. And in truth, in reality, is actually exactly the other way around. If you're playing buzzword or the bull word bingo, while talking to people who actually do know what you're talking about, they immediately spot that you're just throwing around with fancy words. So don't do this. And this is why the bull bingo is basically just the more realistic term for the buzz bingo. So yeah, don't do that. Don't do that. Unless you're at a party and you're doing it for comedic value, so you're kind of overdoing it a bit. That's perfectly fine, but that's a whole different story. This is being at a party and just trying to be the comedian that everyone wants to invite to their own party, because look at that guy. He's the reason why we had so much fun. So yeah, we check. Let's see. We check our fire cooldown. If that's greater than 0, if it's we can't check for if it's not 0, because then we would because I only want to reduce the value if it's still above 0. So this is why I can't say, okay, I just want to check if it's not 0, which also my IDE complains about for some reason. Because equality comparison, floating point numbers, possible precision, rounding errors. And they will come. Trust me, I've had this. There will be rounding errors. It's guaranteed. There's a 100% chance that this will return in rounding errors, and eventually this might cause a problem for you. Which is one of the reasons why we do not want to check for not 0. But the other reason is if it falls below 0, if it becomes negative, this would still say, yeah, it's not 0, and we would still reduce the delta time, so it would get even more not below 0. Anyway, I only want to reduce my cooldown for as long as it's greater than 0. So, and if it is, we just say, and this is a nice shorthand. I'm not sure if we talked about, we talked a bit about the shorthands because we just used them here. Let me write 2 lines for you. Let's hope the year 2021.99997 will become better. Yes, exactly that kind of. This is something you would get. Absolutely. You hit the nail on the head. Yep. So let me write 2 lines for you. What we want to do is we want the new value of our fire cooldown is supposed to be the current value of our fire cooldown subtracted by time, delta time. Again, if you have no idea about delta time, my quick rundown a few minutes before of what delta time is didn't actually clear up all your questions. Just go the session before the last one. We talked in excruciating detail about this, so I'll spare you me. I don't know, rambling. Now rambling is more negative. Me senselessly talking about this because we've already done this. So this is basically what we want to do. Our new value of fire cooldown should be our current value of the fire cooldown subtracted by the time delta time. This is perfectly fine. You can do this. However, my IDE is already complaining. It's not complaining. The green ones are not complaints. The green ones are suggestions. The complaints start with the yellow ones. And there's another thing. There's a shorthand we can do. Because look at that. I can do fire cooldown, and then I can use the shorthand of minus equals time delta time. And these two lines are absolutely, exactly the same. They are not only twins. They are perfect clones. They are absolutely 110% the very same thing. Because what this is just a short version, a shorthand version of this. But this is exactly what it does. What we're doing here is we're taking our current value of fire cooldown, subtracting the delta time from it, and setting this as the new value of fire cooldown. And what this does is it takes the current value of fire cooldown and subtracts the delta time from it. And leaves it and leaves the new value in fire cooldown. So if we want to add or subtract values to or from a variable, like this up here is another example. We want to add our horizontal movement onto our new position X value. So the long version would have just been new position.x equals new position.x, and we add the horizontal movement to it. Again, this is the very same thing as this, only that this is way shorter, less to type, and we like this. We are IT people. We are lazy. We like to type less. And some people even say this is better readable. Because here you first have to see, okay, I'm assigning a new value to this variable, okay, and I'm actually taking the current value and I'm doing something with it. And then I'm storing the new value in my. All right, okay, cool. While up here you just see, okay, I have this value, I have this X value, and now I'm going to add something to it. And what I'm going to be adding is this. Bam. So yeah, I think this actually is more easy to read. Same with here. Okay, we're taking fire cooldown and we're subtracting something from it. We're just subtracting the delta time. Wonderful. And this is exactly what we do. So this is just a very convenient shorthand you will see everywhere. I do not know a single person that's not using these shorthands. Still, if you say, nah, I like this more, I do not want to use the shorthands, perfectly fine, because technically there's absolutely no difference, and this still it's okay readable. So if you want to do, if you say, nah, my code should be adhere to the best practices there is, and how everybody else immediately understands my code because they are doing it the same way, then I would suggest use the shorthand. And if it's just because you're as lazy as me, it's just less to type, and I like this. So we check if our cooldown is greater than 0, and if it is, we're going to be subtracting this, and there's two things, and this is why the greater than 0 is quite important, because depending on what the current value is, because of all the frame timings and stuff, we might, but I think this is even this not sure how probable this is, or how likely this is. We might actually end up with a fire cooldown of exactly 0. Might happen. Because if the fire cooldown is 0.016 and we're at 60 frames per second, so the delta time since the last frame is 0.016 seconds. Yay, we subtract that from each other, we end up with a perfectly fine fire cooldown of 0. So this might not happen. It might be that there's this one frame took 0.017 seconds or only 0.14 or whatever. So this might actually go below 0. We might actually end up with something like negative 0.001 or something. And this is why we're checking if it's still greater than 0. So no matter if our fire cooldown hits exactly 0 or a bit less, perfectly fine. This will not catch anymore, and we won't subtract any more from it. And this also goes with this condition where we check the fire cooldown not to be equal to 0. I did this already foreshadowing what we're doing here, because this might actually end up in us not being able to fire at all anymore if this doesn't perfectly result in 0. If this goes a bit below 0, then this won't trigger, this won't catch anymore, and we can't fire. What we could do is we could put down something down here. We could either do a clamp. We could use the mathematical library and clamp the value between 0 and whatever on the positive side. We could do another if condition. If the cooldown is below 0, we just set it to a perfect 0. But I don't think this is necessary. Also, this takes processing. Just that one line might not do much, but if you do this on a million places in your code, this might actually have an impact on performance. So we just say, even this is easier to code. Again, be lazy. Be lazy. Try to use as less code as possible. Be effective. So this is perfectly fine. We just see, okay, if the cooldown is 0 or maybe even below it, then we know the cooldown's over, we can shoot. And the same thing was here. So it's perfectly fine. So the last thing we need to do is, you see this is still in gray. We actually need to call it. Well, we made this neat and little new function. So let's put this before our fire projectile method. So we can fire the exact frame where our cooldown has cooled down enough. We can fire because we checked the cooldown and it might hit 0 or a bit lower. And if it did, the cooldown is over and we can immediately fire again. So this should already work. If I save this now, let Unity compile. And once it's done compiling, sometimes it takes some time for that. We should... Oh yeah, look at that. That looks nice. That looks nice. Let me wait. Let me maximize this a bit and move this a bit more towards this. So trust me, I keep my control key pressed because the control key is the one we're assigned to this axis to shoot, and you can see every second there's a projectile coming, and even if I hit the button and I hit it quickly again, nothing happens. But if I hit the button once, wait a while, the cooldown is cooled down, I can perfectly shoot again. And even if I do the rapid fire thing on my control key, nothing happens for as long as the cooldown hasn't gone down. So very, very, very important mechanic. You see this all the time at all the places. Yeah, but quite easy actually. It only took so long because it took me so long to, I don't know, say so many unnecessary things. I don't know. But yeah, this is basically the cooldown. But we still have the one problem. See, even if I hold my key now, you see, we're spawning one projectile at a time. But even if I let go, see, I'm not pushing any buttons. I'm not holding anything. Our projectiles, they stay there. And if we shoot and we look up, can we look up? See, we can see the projectile. See, and it keeps flying. It keeps flying. Let me try to maximize this. Maybe we can see it. Not sure if I can see this because by now they are only a pixel in size. But wait, let me see if I maybe can do something with the old magnifying thing. Yeah, not really, because they are already so far away. But you can see them glimmering and flickering, but maybe not, because the video compression for the stream completely kills it. But you can see them in the list, in the hierarchy of the level. You can see they're still there. So while we have solved the problem of the 2 rapid fire, we have not solved the problem yet of them sticking around basically forever until we end until we terminate the game. Oh, that is going to be to say syntax error if you use yeah. You need a bit more. This is a thing only since some time. The old 8 and 16-bit and even some 32-bit thingies, they don't know about these shorthands. You have to do some more modern. You have to use some more modern programming languages, or at least C. I think you can. I mean, it's the C64, so it only makes sense you can program it in C as well. And if you have a good cross compiler, your C should always be able to use the shorthand of minus equals or plus equals. There's also the star for multiplication. There's a multiply equals. There is I think there's even a divide equals, even though that looks a bit weird. And there's a few more. In PHP, even there's dot equals for concatenating strings, but that's PHP. That's a completely different story. But yeah, another thing we might try, because just because why not, if we go to our main player cube and we look at our movement component, remember we've set the firing cooldown. We made this a configurable variable, so I could say, let's make this 5 seconds maybe. Let's put a 5 in there. So that should give me quite a slow frequency. There's another one. That should give me quite a slow frequency of shots. So this is, I don't know. Not sure how usable this is. But we could also set this to like 0.5. So this gives us a bit of a quicker frequency. Or we just set it to 0.1. And then we actually have our rapid fire. But even at 0.1, look at it. And I'm going to be moving this a bit more closer to the camera again. Even if 0.1 of as a cooldown, okay, this is maybe too close. Down. Oh yeah, down. I must exit play mode I do not want to save this scene. I was I was shooting, which is the control key, and moving down at the same time, which is also the shortcut for save scene, which I do not want. I just want shoot and move down at the same time. So you can already see, even if we set it to 0.1, we have a way more nicer rapid fire, because they are not just stacked into each other. So there's still a bit of a delay till we can fire again. And let's try setting this to, I think 0.2 might be a nice rapid fire. And if we go to full screen then, and yeah, see, this is a nice rapid fire. This is something, if this would be a space shooter, this is a nice rapid fire. When you picked up the rapid fire power up to kill all those nasty enemies that are coming towards you and they want to kill you. So let's tackle the next problem, because you can again see we have all these, even with our cooldown, we have all these projectiles that are still going. We do not want that. So again, there's multiple ways to handle this. There's an easy way. And there's an, in my opinion, very, very nice way. And I'm going to be showing you both. So, we move into our player projectile controller. And that says some bad programmed games do not kill objects too, which results in the computer device getting slower and slower until it freezes. Exactly. This was exactly my point. We've seen this at the very beginning. It took a while because this is quite an okay CPU, so it can handle a few things. But during my opening monologue, I kept spawning these projectiles with our super hyper rapid fire with one projectile per frame, and eventually you could see that they started to stretch out. They started to develop a distance between each other, because since there were so many projectiles, the rendering time per frame grew larger and larger. So the delta time was bigger. So, and there were more frames between that. So they actually started to grow a distance between each other, because the CPU started to need more time than it was supposed to, because there were so many objects. But it's exactly what you just said there. This is exactly the problem that we want to prevent. So there's two ways. There is the very obvious and easy way, where we just say, okay, we give this, and we can actually make this let's make this a serialized field, and let's call this projectile lifetime, and that is, let's give this 5 seconds. Let's make this a default projectile lifetime of 5 seconds, and then we can basically do the very same thing that we did for our cooldown. So we can make another method, and that's a private void, and we call this check lifetime, and we basically do the very same thing. And you know what? We actually do. What do we do? What do we do with a drunken sailor? We could we could not manipulate this one, because once we change this one, this is changed. Yeah, but it's destroyed anyway. Nah, let's make this clean. Let's make another private float, and let's call this lifetime, or current lifetime. Or time alive. No, even better. Let's call this time alive, because this will be the time, and this initially is also 0. It's always a good idea to initialize your variables with a default value. Another way of doing this, and this is actually my preferred way. I actually do not like defining the defaults up here, but this is personal preference. Another thing, we deleted the start out of here, right? So let's put the start back in. We could just leave this uninitialized. We could just private float it. The field is declared, but we have no idea what's in there. Could be nothing, could be everything. And in our start or the awake method, we can then just say time alive is 0, because we haven't been alive at all so far. We just came to life, and now it's complaining assign never used. Yeah, we're going to be changing this. And then we got our check lifetime. And what we do is, again, we see if our time alive is still below our projectile lifetime. So what we're checking here is we see if the time that we have been alive so far, and remember, we are now in the projectile controller. So this is the component, this is the code that runs on the projectile we're spawning. Remember, we have, oh wait, let me fetch the old magnifier. We have our player projectile prefab here, our prefabricated game object hierarchy with everything on it. And if I select this now, you can see we've put our, where is it? Oh, here. We've put our player projectile controller script on top of it that also handles the movement, because you've seen when we spawn our projectile, our player object does not have to care about the projectile flying its way. All we do, let me get rid of the thing here. All we do in our movement controller, which is basically our player controller, all we do is, and where do we do this? All we do is we instantiate the projectile, the new projectile. We spawn a new projectile, and then we're giving it a sensible starting position. We're just telling it where it has to begin its life, where it's supposed to be. Because if we didn't do this, it spawned in the middle of the level, always at the same place, no matter where our player is. So that didn't make any sense. So after we spawned our projectile, we are moving it to the top of our, to where the top of our player object is, to actually create the illusion of the projectile actually shooting out of our player object. But that's it. That's all we do. There's nothing more that we do in our movement, in our player movement controller in regards to the projectile. We just spawn it, give it a sensible starting position where it should begin its life, and that's it. Because we have our player projectile controller as a separate mono behavior, again, this is the components and all the things you can put onto a game object. And this thing actually takes care of the moving of the projectile. So the projectile has its own piece of code attached to it, so it just moves straight up and goes its way. And this is the code where we're currently in. And in this code, we have this lifetime now defined and the time alive. And we have our check lifetime. And for as long as our current lifetime is below the lifetime we have, so we have not reached the maximum lifetime of our projectile yet, we want to add the current time onto it. So we say time alive, again, plus equals the shorthand, because we're just adding the time, delta time, onto it. So basically in our time alive, we are counting the time that this object has been alive for as long as it's below the maximum lifetime. So now we need to do something when this is reached. So when this is not the case anymore, so our time alive, if the time we are alive is still below our maximum lifetime that this projectile is supposed to exist, we're adding up to the time alive, so we keep track of the time that thing exists. In the other case is, and we could put this as an else statement, because it's either this or that. So if this isn't the case, if time alive is not below our maximum lifetime, well, the logical conclusion is then it either reached the maximum lifetime or is maybe even a bit over it already. We can put this into the else statement of the if. And then we want to do something. So what do we want to do? When the maximum lifetime of our projectile is reached, we want to get rid of the projectile. We want to destroy it. And that's exactly what the function is called. The function is actually called destroy. And the parameter is the game object that we want to destroy, because destroy not only it doesn't destroy the object the object it owns the code that's currently running. You have to tell it the object it's supposed to destroy you. So also you can have at some other place in your code, you could have a function that greets Mooney Machine when they come into the chat. But we don't have this, so I have to do this by my own. So, Mooney Machine, hi there. A wonderful evening to you. And thanks for joining. Hi. We have to tell destroy what game object it is that we want to destroy, because you might at some other place in your code, you might have a huge list of a lot of game objects that you either spawned or in any other way you got a reference to. And for whatever reason, you want to destroy one of these objects. You just say destroy, give it a reference to the object you want to destroy, and kaboom, it's gone. And conveniently, since this extends the mono behavior that's supplied to us by the Unity engine itself. We already have a field in our class that holds a reference to the game object this instant is currently attached to. And this is conveniently just called game object. That's it. This value, this game object, references the game object in the scene that the instance of this class is currently attached to. So remember, we have when we shoot our way, we have multiple projectiles that are in the hierarchy of our level, and each of these projectiles has an own instance of our projectile controller script, and this instance knows a reference to each and every single game object that it's attached to, using this game object value variable. This reference is the game object this is currently running on. So now we have either or. Either our current time alive has not yet reached the maximum time, then we just add up the current time, so eventually we can reach it. But if not, if this is not below, so if we have reached our maximum lifetime, we just call the destroy function on our own game object, and in theory, the projectile should go away and free up capacity. And again, we have to, now that we have made up this method, we just have to call it, which we do conveniently in the update method. We just call the check lifetime. That does all these neat things. And then let's see. Let's Unity compile and let's try. Let's run this. I won't maximize this yet because we want to take a close look on our hierarchy. So yeah, let me fire a few shots, and you see the first projectiles, they spawn. And now, even though I'm still shooting, it looks like there is no new projectiles coming into the scene. And that is because our maximum lifetime pretty much matches up with our cooldown. So every 5 seconds, one projectile dies and the new one is immediately spawned. So if I stop shooting, you can see how the list of player projectile clones goes down again and they all vanish. So let's see if we can track them by looking up a bit. There they go. Okay, they are quite far away. Maybe let's just set the cooldown a bit smaller. Let's say, I don't know, let's say 2 seconds. Maybe we can see this. And yeah. Let me shoot a few. Need to maximize this a bit, but then I can't shoot. But I think you can see how the projectiles. Or let's even, you know what? Let's even set the cooldown to, what was it? 0.2 was the nice one, right? 0.2 was a nice cooldown. So now we have the rapid fire again. And remember, before we could see the projectiles flying off into infinity. And now you can see how there's one point where they stop. They don't exist anymore beyond this point because this is the maximum lifetime. Maximum lifetime has been reached and they kind of self-destruct. Does it free up the memory? Yes, this also does free up the memory. All the resources these objects need, they take up, they use, they are completely freed up. So we can do this for hours. We can now sit hour after hour here. Rapid fire, or we can even let's set this to super rapid fire 2.1. We can sit here for hours and shooting these projectiles, and we will not have any resource issues. The CPU will still be cool. The memory won't fill up, because we're getting rid of all these objects, and this frees all the resources they use up. It's kind of like they never existed in the first place. The garbage collector will find them and handle freeing the memory. This is a feature of C#. Exactly. This is what technically happens in the background. Once they are gone, the objects down under the hood, the objects still exist somewhere. They are just not in the scene anymore. And eventually comes the garbage collection, and it will see, oh, there's no references to this object. No one's using this. Anyone? Does this belong to anyone? No? Okay. And in the trash bin it goes. And then everything's gone. So this is quite a nice way to handle not having an infinite amount. And let's set the projectile lifetime back to 5 again, because for the other thing I want to implement. So let's try this again. Now they should be... Oh yeah, there they go. Okay, now they go way more further up because they have more time before they basically self-destruct. The destroy method of Unity, there's some other things, but anything in C# that loses reference will be cleaned up. Exactly. Yeah, the destroy thing actually does quite a few things. There's quite a few if you implemented all the methods the mono behavior actually offers, like. There is an onDestroy method. There is not sure if the onDisable is going to be called, but you can actually react to your object being destroyed. It's not immediately thrown away. There's an onDestroy method that's going to be called before the object is actually removed from the scene. So if you need to do some cleanup or you want to do other stuff, you can do this. So calling destroy in a game object down under the hood. There's a lot of stuff happening, but this goes light years beyond the scope of this tutorial. All we need to know now is if we want to get rid of a game object, no matter what it is and no matter why, we just call the destroy function on it, and the engine handles everything that needs to be handled. Yeah. All right. So. This is a neat way already to handle the infinite spam of if you're spawning objects like projectiles and you want to get rid of them, you can just give them a lifetime or implement any other means. Maybe if you wanted to be super fancy, you can calculate the distance to the player or the distance traveled, or there's so many ways of doing this. But basically, and in my opinion, this is the most nicest way of actually handling this situation, because basically, if this is like a space shooter, if the projectile leaves the visible screen space, we don't need it anymore. So let's is it run? Yeah, let's maximize this again. So basically, we do not need the projectile anymore when it reaches the border of and it leaves the visible area of the screen. And this is not tied to a fixed lifetime, because if I'm up here, there's way less time till I do not need the projectile anymore. And if I'm down here, there's quite some time. Because if we set the lifetime too low, let's try this. If, for example, we set the lifetime, where is it? It's here. And if we set the lifetime to, let's set this to 0.5 maybe. Not sure if that works, but let's try. We actually might have a situation where the projectile, where the projectile gets destroyed or despawned or whatever you want to call it, while we would still need it. So giving it a lifetime is already a nice way of handling this, but it's not perfect because either they are living for longer than they're needed, or they are not living long enough. So in this case, a nice way of handling this would be to check if the projectile left the visible screen space. If the projectile went out of the screen, it's not seen anymore. So you basically don't care because there's no enemies outside of the screen. You're only spawning your enemies right on the screen. So once the projectile left the visible area, we don't need it anymore. So we can destroy it. And there's actually a way to do this. And we're doing a short break, a minute or two, for everyone to take care of everything that you need to take care of. And when we're back after this short break, again, it's just a minute or two, so no need to run away yet. We're still continuing. But we're looking at an example how to handle this, because there's a quite convenient way of finding out if our object is visible, if it can be seen by the current camera, so by the game. And once that's not the case, we can destroy it, no matter how much time is gone by. Yeah, and we're going to be taking a look at this in a minute or two. I'm going to be lubricating my throat, and see you back in a couple of minutes, and then destroy the projectile exactly at the moment when it's not needed anymore. See you in a minute or two, or maybe 2.5. It's a float value. The minutes are a float value. Maybe it's 2.37 minutes. Yeah, that's a good value. So, I'm not sure if that actually was 2.37 minutes. It might have been a bit more. It might have been a bit less. I don't know. I didn't actually look at the watch too closely. So, let's dive back into it. There's already some discussion in the chat about games either not properly despawning or not properly spawning their stuff. Like, you look at an NPC, you look away, you look back, and it's gone. Poof! It just vanished. Or the other way around. That mentions in GTA, you just walk down the road, and the road is completely empty. There's no one to the left, no one to the right, no one in front, and especially no one behind you. And then you turn around, and all of a sudden they are all behind you. Yeah. Or you turn around, and there's no one. You look forward, and then you turn around, you look at what's behind you, but there's nothing behind you. And Subnautica does this, and all of a sudden things start plopping in. Because the game now knows, oh, it's visible! It's visible, and you're quite close, so let's spawn things. Yeah, this is all stuff you have to take care about. To spawn the things before the player will be able to see them. And this is we're actually gonna be addressing this at least a bit when in the following example. We do not immediately despawn our projectile. We despawn it a bit later when we're actually sure the player doesn't see it anymore. So this is something you should take care about. So before the player will be able to see your thing, spawn it if you're checking for visibility, or if you're checking for visibility to despawn things, make sure that it's actually completely out of sight, so it doesn't just in the corner of the eye goes plop and it's gone or something, because that is quite distracting. And when Moony Machine summons the vehicle in Cyberpunk, you quickly look away from where you want it to be. Yeah, so I don't know. That does something in the game. I personally haven't played Cyberpunk myself yet, just because I still need to wait a few years because I actually have hardware that will be able to play the game decently. Because I think you should have at least an RTX 20 something to be able to enjoy all the ray tracing, because that makes it just looking so much more nice. Okay, we have this check lifetime, and we can leave this in because by default it's set to 5 seconds. So this is, and we can set this, but there's a handy dandy function. We can just say reset. And everything's reset back to the original values, to our default values. I don't know. Projectile speed 10, was that cool? Yeah, I think that was okay, right? So we do leave it in. We leave the projectile lifetime at 5 seconds. This is kind of our contingency plan. So should something go wrong, and for whatever reason our check fails, at least after this amount of time, the projectile definitely will be gone, even if, I don't know, it got stuck somewhere. Maybe because for some reason the projectile didn't move anymore. The movement speed was set to 0 or something close to it. It only moves very, very, very slowly over the screen. Still, after 5 seconds, the emergency brake will be pulled and the object will be destroyed. Because, it always comes in from off the screen. Oh, okay. See, and this is a nice thing. If you actually understood these mechanics and how they're implemented in a certain game, you can use that to your advantage. You can actually make the game do things the way you want it if you understood the mechanics. It's implemented. You can force your will onto the game. Yeah, when turning around, other assets are loaded in the same location, different cars on every turn. Oh, that's funny. So you mean I look at the street and there's some cars, and I look away and I look again and then there's other cars. Oh, that's quite confusing if I keep looking around. So what if I keep moving my mouse 360 and again and again and again? That might be a stress. The game is quite stress prone already. So let's not push it to the limit. So let's make another method, because we said we want to have everything clean and nicely separated from each other. So don't just slam this into another method. Let's make another method, and we call this, let's call it check visibility. So many eyes in one name. It's amazing. Let's call this check visibility. And before we forget it, let's already call it. It doesn't do anything yet, so we haven't broken our game yet, but we are about to. Well, hopefully not. That would be, that's not the intent. We do not want to break it. We want to make it better. So there is. Oh, no, okay. We want to check for the visibility, and the actual visibility, which is this area where our main game camera, this one, is looking at. And if I go a bit down, I remember it's, what's the rotation? The rotation is weird. Let me copy paste this. So, however, the camera, and what's the, which is the one I want to, yeah, this is the one I want to rotate. So, however the camera is looking, and we might actually try moving the camera around and give it a different rotation, make it look to some other place, so we could actually see the projectiles actually being destroyed when they are not visible anymore. Let me restore this neat and nice. Not sure why this is such a weird number. I think we just did this by hand till this thing looked like it's in the middle or something. So we want to check if the camera is currently being able to see our projectile. And we can't really do this. Well, we can do this with overcomplicated mathematics. In the 3D space, we could see, yeah, is this based on a lot of values? Is this still in the view of the camera? But there's a more easy way, because this area here, the one that the camera actually sees, the area our camera actually sees and renders on your screen for the game view, this also has a special set of coordinates, which are what they are called, viewpoints. I think it's the viewport. The effective viewport, which is this thing here, where our camera sees stuff and shows us stuff that are like, now our player object is inside the viewport because we can see it, and now it's outside. We can't see it anymore. And this is exactly the situation when, at this point, when it's not visible anymore, we want to destroy our projectiles. And the viewport also has a very special set of coordinates. It starts with 0 on the x and 0 on the y-axis, because the viewport is only two-dimensional, because the image you're seeing on your screen is just a two-dimensional representation of whatever is happening in the 3D world. So our viewport is two-dimensional. And it starts with X and Y. I think it's the upper left corner, where everything is 0, and then it spans over to the right, where X becomes 1, and it spans down to the bottom, where Y becomes 1. The y-axis can be flipped, though. I'm not perfectly sure. Maybe the 0, 0 coordinate is down here, and y goes actually up. I'm not perfectly sure. But for our use case now, it actually doesn't matter, because we just want to know if our projectile is still within the visible range, the visible coordinates, which is from x being between 0 and 1. And also y being between 0 and 1, because that is the range of coordinates where in the viewport our object is visible. Unity has quite old film. You can configure the camera however you want. You can configure that however you want to. You can configure the field of view and whatever you like. That's all thing you can set up to your heart's content, however you want to like this. If you want an old movie camera, I think there's even shaders that generate these old running lines and all the dirt. There might even be shaders for this. Yeah. So how do we do this? The first thing is, so we basically want to check the viewport coordinates. We want to know the viewport coordinates of our projectile. And there's actually quite easy way to get this. But what we need to actually get this is we need a reference to our current camera. And in Unity, everything in the scene is a game object, so we need a reference to a game object. It has film reels. Yeah, because that's the way to go. That is the way to go. 70mm film. That's the shit. That's what you want to use. There's no 4K or 8K that beats 70mm film. You need a few more Ks for that. We'll eventually get there. We'll eventually get to enough Ks so you can replicate the visual appearance of 70mm film, but we're not there yet. But give it a few years. Give it a few years, and we're there. And also, we'll be having HDR, and the good old 70mm film cannot do HDR. So yeah, this is why they still have the reel-to-reel cameras, because they know what's good for them. They know the professional stuff. So that's why they're using 70mm reel-to-reel cameras. So your game image is actually the best it can be. It's perfect. Almost. You just have to put a nice scene into there, which we didn't, but well, this is beyond the scope of this tutorial. Maybe someday there will be someone who make a nice level design tutorial or something. Yeah, but that won't be me. That won't be me. If you check the box of the camera, it opens a bunch of settings that replicate a real camera. Yeah, as said, you can set this to your heart's content. There's everything. There's only very few things you can't configure, and those things you can't configure, you can make them work the way you want with additional code. So yeah, you can really set up your camera however you like. For now, we only need a reference to the camera. And again, everything that's in the scene is a game object, and our nice little reel-to-reel camera is in the scene. So it's a game object, and it's conveniently named main camera. Let me copy-paste this already, because we're going to be needing this. Don't forget to add lens flare. Yes, lots and lots of lens flares. I'm a huge fan of lens flare. I do not like, I actually hate, I can't stand motion blur. I really do not like motion blur. It's the first thing I disable if there's an option to disable it. And if there's no option to disable it, I won't play the game, because motion blur, total no-go. But lens flares, yes. The more the better. Well, I never thought this, I never thought I would ever say this. But there is such a thing as too much lens flares. Yeah. And the perfect example of that is the newer Star Trek movies. The Star Trek movies that play in the Kelvin timeline. They actually demonstrate there is such a thing as too much lens flare. I did not think it was possible. I did not think that was a thing. But yeah, it is. So anyways, we need a game object, and we call this main cam, because this is going to be our main camera. And then we also going to be fetching the reference. And this is, oh, look at that. This is my IDE already pretty much knowing what I want to do. So there is the find method of the game object class. And this is to be used very, very delicately. And basically, we should not do this right here. This is actually totally the wrong place to do this. But first, let's do it, and then let's move this to someplace else. Because the find method, it costs you. It's expensive performance-wise. So, since we are going to call check visibility each and every frame, because, and see, my IDE already tells me, dude, that's an expensive method invocation. You should think about this. So this is actually really something we do not want to do, but we're going to be correcting this in a bit once we've actually finished this one call. So yeah, we're calling check visibility in the update function, which means we're calling it each and every frame. So with each and every frame, we are fetching the reference to our main camera. Because I give this the name of the object I'm looking for. And it gets even worse, because we don't only want the main camera, we actually want the camera component. We actually want the camera component that is attached onto this game object. So this is the cam component. And another really expensive and really bad thing we're gonna be doing, and this really should be avoided as much as possible. Only call these methods if there's really no other way. Sometimes there's other ways, like you can in the inspector already drag a reference to something in there. Do this. So this should be avoided as much as possible. Sometimes it can't be avoided, and then put it somewhere where it's not in the update method. But we're going to be tackling this in a bit. First, let's finish this, because what we need is we have the main camera. No, not camera main. I want my main camera variable up there. And there should be a get component. And this is quite interesting. And this is the camera component. Because we already established that all of these mono behaviors, they are components. They are components you can attach to any game object. So in our case, we've made our movement component, and we have made our player projectile controller. That's also a component. And we have attached these. To our objects. Like the main player cube, we attached our movement component onto the player cube. So this component then affects this cube. And so we also attached our projectile controller thingy there onto our projectile object, the prefab that we built out of it. And you can also get all of these things if you want to, because eventually your components will grow to a point where they will have methods that can be called from the outside, or they will have values that can be accessed from the outside. So you can get all these components with the get component method on a game object. You just call get component on a game object, and in these triangly spiky brackets, you state the class name or the type, and then you will get a reference to this component. And again, this should only be used if there's absolutely no other way. You should try to avoid this where possible. Quite often it can be built in a way that you have a field for a reference here in the inspector, and you can just drag the reference to this component in there. If that's not possible, and if there's no other ways, then you can call the get component but. And again, this is pretty much we're doing this right now, because right now we're doing this each and every frame. The thing is, and you can see these red lines, and they are not squiggly lines, they are actually hard red lines. Yeah, writers suggested me that I put this immediately up there, but I don't want this, so that's why I don't do it. This is a bit more clear to see. This is our variable declaration, and this is where we actually use them. This is all in here. It just tells me that it's not used yet. We put something in there, but it's not used yet. We're going to be fixing this because we're going to be using it. But first of all, we got the object, and then we got the component, the camera component from the object. And that's bad. This is the red line to tell this is really expensive calls. And doing this each and every frame will with certainty kill your performance. And also, we don't have to do this. We don't have to fetch a new reference. You was referring to camera main. Yeah, it suggested me something that I didn't want to do. It suggested me, yeah, you have the reference there, but I actually wanted to demonstrate these functions. So it suggested me the wrong thing. It suggested me something I did not want to do. It's like I'm going into the elevator and I want to go to the 4th floor, and the elevator suggests me I could go to the 6th floor. But I don't want that. I want to go to the 4th floor, even though the elevator might suggest me the 6th floor is nice. But that's not what I want to do. So this is very expensive, and we don't have to do this. We don't have to refetch the references each and every frame. We can just do this once, remember these references, and be done with it. And that's exactly what we're gonna do. So we're gonna be moving these two. Okay, I have to Control X them. We're just moving those up here. So we basically make them fields of our class and also properly name them then. So instead of these being local variables in some method, we just promoted them to be fields of our class that we can now, and also we have, and I'm a bit lazy, so let me copy paste this. We have to set the visibility. So we can now access these fields, these values from wherever in our class. Let's say from our start function, which is called each and every time while the game is running, when this object is coming alive and is being enabled. So let's also move this code. Let's move it into the start function, and let's fix the names. So what we did now is, this is only called once, and this is still expensive. These are still expensive calls that should be avoided, but we only do them once when this thing is instantiated. Another thing you could do, but that's going beyond the scope of what we're trying to do in this tutorial, is you could have like a game manager, a more central place where you can store these references. And then when the projectile is spawned, you can already pass them in, or you have a way to fetch them from another place that's less expensive than this. This is all things you should do, and you actually end up needing to do if doing this in an actual production project. But since this is just for demonstration purpose, we're going to be living with this. This is good enough because the projectile, it's spawned, it comes into life, and we're only calling this once. And that's pretty okay already. We're doing this for every projectile, which can be optimized, but that might be homework for you to come up with a way to optimize this. But we're remembering this, we're fetching this once per projectile, and we're just remembering these references up here. So now, in our check visibility, we can just use them. And we have the camera component. And to make this a bit more clear, I should actually rename this to main camera component. To make it a bit more clear and not to confuse it with, I don't know, maybe a camera component that's attached to this object or something. So yeah, let's call this main camera component so we actually know what we're dealing with. And this main camera component has a wonderful function that does exactly what we need. Because remember, we want to check if our projectile is in the visible area inside the visible coordinates of our viewport. So that means we need to get these values. We need to get the coordinates of our projectile on the viewport. And again, you could do this with overcomplicated mathematical things and calculate them by themselves. Totally possible, but you don't have to, because the camera already knows. And there it is. There is a very, very, very convenient method called world to viewport point that interestingly enough gives us a vector 3, maybe because there's no such thing as a vector 2. I actually don't know. Is there a vector 2? But anyways, it gives us a vector 3, but only x and y are of interest, because in a two-dimensional plane, there is no z value. But this is exactly, this is what we need. We want to translate world coordinates to the viewport coordinates where our object is on the 2D plane that the camera projects onto your monitor. And what do we want to convert to these viewport coordinates? Well, our current position. And our current position, we've talked about this the last 2 evenings, is in transform.position. And if we now give this a nice little variable where we can remember this, let's call this viewport position. Yeah, and let's even split this up again, because that's just how I like it. This is how I roll. And there's a semicolon missing, like so. So now we have translated, and this is all the magic. This is the one function you need to remember. This is the one function you need. The world to viewport point of the camera component. And it doesn't. I think it doesn't even have to be the main camera, because this thing just translates one coordinate to the other. And now we have a vector in viewport position that tells us the 2D coordinates inside this viewport. So if it's again, don't quote. I'm not 100% sure if x goes in which direction x goes up and which goes down. Either in this corner up here or in this corner down there, x and y are 0, and then they grow up to 1 to the other side, to the, so either this one or this one, depending on where x. Well, we could try this, but for our purpose, it's actually not necessary to know this, because we just want to know if it's inside of those coordinates. So it's between 0 and 1, and the same goes for y. And we have our coordinate, like if that thing's if that thing's right in the middle, it's at 0.5 on the x and 0.5 on the y. If it's more like here, it's close to 0 on the x and 0.5 on the y. I hope you this is understandable. You know what I mean. So this is the kind of the pixel based coordinate on the 2D field where that thing is. And all we have to do now is to check if these values are within our defined allowed values. And since the visible space of the viewport goes from 0 to 1 on both axes, we just have to check if one of the axes, if at least one of the axes is either below 0, because then it's off to the side, to that side, or if it's above 1, then it's off to that side, and the same goes for the x, just for up and down. And if that's the case, then we just destroy our object, because it's not visible anymore. So we're gonna be making a neat little if. And I will even separate this into multiple lines. And spoiler alert, it's going to be 4 separate lines. Because what we want to check is if our viewport position on the X value is below 0. But remember of what we've talked a few moments ago, to make absolutely sure that thing isn't visible anymore. Because in case of the projectiles, I think it won't be such a huge thing. But think again of the cars that we just had in the chat a while ago. If you have a car that moves out of the visible space, the coordinate might already be below 0 because the car drove out of the left side of your screen. But since the car is so big, it's such a big model, you can still see like the trunk of the car. So if you despawn your car exactly when your coordinate reaches 0 or goes below 0, the player might see the trunk of the car mysteriously disappearing. So the car might start driving out of the frame, and all of a sudden it disappears and vanishes. And again, there's a lot of ways to handle this. You could put in more sophisticated checks and check for more things, or take the size and the distance into account. All these things, but quite easy and perfectly fine for our demonstration purposes. We just not check if it's below 0. We actually check if it's like maybe below negative 0.1. So that means it reaches the left side of the screen, and then it moves a bit further. But it's still this condition still doesn't catch, because it's waiting for the coordinate dropping below 0.1. So the object, or our projectile in this case, it moves a bit further outside the screen to make sure it's actually completely everything of it, even the trail and everything, is outside of the visible view, and only then we despawn it. So this is a very simple way of dealing with this, and for our demonstration, this is more than enough. And we also do the same with the other direction. So we not check if it's greater than 1. We check if it's greater than 1.1 to give it a bit more way to move out of sight before actually destroying this. And then we're going to be doing this for the y-axis as well. And again, we're also checking. Well, the x-axis is actually not that important because we're not moving on the x-axis, but I'm just putting this in for completeness sake. For us, for our actual example here, the y-axis is more of interest. So I'm checking if the y-axis dropped below negative 0.1 or above 1.1 and not just 0 and 1, to make sure that our projectile actually moved enough out of sight to not mysteriously disappear, but actually just be gone, and the player knows, oh, okay, it's gone, it moved out of the screen, I have no idea where it is, and basically I don't care, as long as I can shoot another one. And then there's only one thing to do. There's only one more thing left to do, and we've already done this. Because if one of these, because they are ORed together, so it's enough if one of these separate conditions is true. Well, we want to get rid of the projectile because it's not needed anymore, and we've already done this. So this is basically a call to destroy the reference to the game object this code is currently attached to and running on. And in theory, this should be it. So there's only one way to find out. Let's save. Let's Unity compile. And let's try this. So, start this. I'm going to be moving that camera a bit, like, so we have more to see here. And then let's see what's... Oh, and look at that. See? If you look at both screens, if you look at the upper screen and the lower screen, let me move down a bit, so there's actually more time for the projectile to travel. So if I shoot, see, the projectile goes quite a long way, and you can see we can also see the projectile here in the scene edit view. And once the projectile has left the visible area, what the camera can see, you can see up here it actually disappears. It's around here where the projectile flies a bit, and once it's moved, we can, you know what? Let's make the movement of the projectiles a bit slower. Let's make it like this might be quite slow, but let's try this. Yeah, I'm not interested in displaying this. I actually want to show that the important thing is that the projectile actually despawns. It actually goes away. So now it's quite slow, so I have more time, and see when this thing actually, and see could actually the checking for the 0.1 more in each direction even was a bit, maybe we should have done like 0.2 or something, but it's okay. For demonstration purpose, this is fine. So see, it moves and moves and moves, and eventually it gets out of what the camera can see, out of what our screen here, what the player actually sees, and then the object, it just gets destroyed. The projectile will just despawn, and if we are firing further up here, there's not that much time. You see there's only quite a small amount of time the projectile lives, because it reaches the screen quite soon. And now this projectile has quite some time. Okay, and now it reached our maximum. We've set the maximum lifetime to 5 seconds. We should maybe set this to, let's set this to 10 seconds or something. This was our emergency brake that just triggered here. Because the object was destroyed by our timer rather than getting out of view. And there was, there's another thing I want to demonstrate, because this is actually based on the view the camera sees. Because if we now rotate this camera, which was it? Was it the red one? Yeah, it was the red one. If we now just, I'm not moving my player. See, if I shoot, my projectile quite quickly moves out of the visible area of the camera and it despawns. And I'm not moving my player. I'm not moving anything. I'm just rotating the camera so it looks at a different angle. And when I shoot now, the projectile stays alive, even though it's at completely different coordinates in the 3D world. But since the camera, and if I even if we make it like SpaceX when they're trying their spaceship prototypes. Okay, this was again our emergency brake, because we still have the maximum lifetime currently set to 10 seconds. Oh yeah, and if the camera doesn't see the projectile at all, it immediately despawns. So let's get this a bit back. But yeah. If I follow the projectile with the camera, it just doesn't despawn, because it's still always visible, unless our final timeout hits and says, okay, this is the absolute maximum lifetime. I'm pulling the brake here. But also the other way around, if I shoot my projectile and let my camera move down, the projectile despawns and gets destroyed immediately when it gets out of view. So this was the second thing we wanted to talk about today. How to get rid of all the projectiles we're going to be spawning, because not sure if the speed, yeah, I didn't reset the speed. We had the speed at 10, right? And actually, let's make the firing rate, let's make our cooldown, let's make it Oh, let's make it 0.5. That's okay. 0.5 is good. So now I can shoot lots and lots of projectiles, but we're not ending up with an endless list of instantiated objects and prefabs, which will eventually eat up our performance. But we're cleaning up, everything's nice, and we only have those projectiles actually somewhere in the scene where as for those that we actually need. We only have those projectiles in the scene that actually still serve a purpose, that are still able to hit an enemy or, I don't know, do some other stuff. And another thing is, we're not only killing, and this is, I think, a quite interesting thing and something I definitely like to remember, because I find this is super handy. We're not just killing our projectile based on time or some super complicated stuff that we need to come up with, because you can just with one single, this is the engine, does everything for you. You can just transform your 3D world position into the viewport and then just check if that thing still visible. And you don't have to use this to destroy. You can do all sorts of stuff. You can have lots of objects in your scene that are disabled, so they don't need any performance, but they are already there, but they're disabled. They don't run any code. They're not visible. But once they come into view, you can enable them. They can do their thing. They can use up your CPU time. And once they get out of the visible view of the camera, you could disable them again and then re-enable them again when they get visible again. Yes. And thanks for the nice words. And thank you, Mooney Machine. Thanks for the kind words. Glad this was hopefully of help for some. Again, if there's any questions, if there's any further questions, I'm more than happy to answer any questions you might have. And also, Mooney Machine mentioned this a bit before when I was talking about you could pass like this camera, these camera references, the reference to the camera component. You could pass this in from the outside when this thing is instantiated. You already mentioned something like dependency injection. This would also be something I would love to talk about. Maybe this would be a mini series of the tutorials. Like, not sure if I want to call it advanced coding techniques, but for the sake of not having a better name, let's call it that. That would be actually quite interesting, I think, to do a few evenings about talking about dependency injection. What is it? Why is it? And how do we do it? And all these sort of things. So, yeah. I hope the main takeaway of the second part of how to get rid of things we don't need anymore is the world to viewport point. Viewport point. That's a nice function name, by the way. Method of the camera, because this is super useful, and this is, I think, a nice example of how to use it. So yeah, now you got two very neat ways how to get rid of your objects once you've spawned them. How to get rid of them. First of all, how to get rid of them at all using the destroy method. And then two examples. One is doing it on a time-based thing, and the other one on actual visibility. So I think now we have something we can build upon. And next week, coming up next week, now that we can shoot, now that we have projectiles we can shoot, let's actually shoot something with them. Let's make another prefab. We basically know how to do prefabs, but I think it's a good exercise to make another prefab. And let's make an enemy prefab. Let's spawn some enemies, and let's see that we can actually shoot our enemies down with our projectiles. And for that, we're going to be needing collision. We'll be looking at how we can detect that like if I reset this and if I only move down, and I now launch my projectiles, you can see they are going through this little whatever that shape is that we built here. They are passing right through. They're not doing anything. And next week, we're going to be looking at how we actually can detect that this projectile basically hit this object, and let's make them both disappear, or let's cause damage. And when there's a certain amount of damage, we want the object to disappear, and we want to award points to the player, because the week after that, we will be taking a quick look at UI, how to display the score the player has. Yeah, that's the plan for the future. And after that, we're basically done. We're doing a quick recap stream, and I hope you bring some questions that we can address and answer. And yeah, we're gonna see how we continue with this at all. All that said, thanks for being here. Thanks for spending your valuable time with me. And yeah, well, what's more to say than wishing you a wonderful rest of the week. There isn't much left. There's only one Friday left that separate. Jesus Christ, my speech center really has some issues today. Yeah, only one Friday left that separates us from the weekend. So have a wonderful weekend and see you around. And have a good evening, have a good Friday, have a nice weekend. Till next time, bye-bye.